Hello, everyone, and welcome to our chapter on statistics. Today's video is going to go over basically an introduction to statistics, the fundamentals. We're also going to talk about the different types of sampling methods. But first of all, what is statistics? It's the science of collecting, organizing, analyzing, summarizing, and presenting numerical information so that valid conclusions can be drawn from them. So in other words, we use it to help us maybe make decisions, inferences, or predictions. And when we talk about this numerical information, this is actually what we call data, okay? So we're basically going to be we collect data and then we analyze that data. How we analyze it, well, that's what we're going to go over in the next few sections of this chapter. Different types of what we call descriptive statistics. So let me just discuss that for a minute. That is actually dealing with not only the collection of the data, but organizing it, analyzing it, and also presenting the data. We also want to look at what describes the data, right? That's the descriptive statistics. So we might set up some tables, charts, and so forth. We talk about different aspects of the data. What are we seeing with the data? And then from there, we can kind of try to make inferences from that. And that's what we call inferential statistics. So we make inferences about the data that we've just collected, make generalizations or predictions. And then there are two things to talk about here. And you know what, with this one, just to make it nicer, I'm going to actually just type this so that it's not so messy. But we're talking about, there are two things when we're doing a study with data. We can take our numbers from the population and we can take it from a sample. The population is the total group of items, being studied, okay? It's the total group that we're looking at. It's all elements of interest. So let me just give you an example. Let's say I wanted to look at the overall average grade for one of our math courses at the college. The population then would be every student taking that math course. Now, if you are at a large college like the one I teach at, we have a lot of students. And so maybe instead of looking at every single student, which would be the population that I'm studying, I'm going to take a sample of the population, which is what we call a subset. Let me get rid of that part. That would be a subset of the population. But here's the key. We want that subset to be unbiased, representative, and random. Okay, very important. If I'm going to take a sample from the population that we're studying, I need to make sure that it's representative of what I'm trying to look at. And we're going to talk about how we can do that in a little bit. We're going to look at different sampling methods that can kind of help us make sure that it's unbiased, representative, and random. But first, let's just look at this example here. And I'll switch over to my tablet. What we want to do here is figure out, well, let me read it first. A group of hotel owners in a large city decide to conduct a survey among citizens of the city to discover their opinions about casino gambling. Describe the population, meaning where are we going to gather our data from? Who's the population? Well, it says that we're looking at the citizens, right? They want to decide about this hotel, and so they're going to conduct a survey among citizens of the city. So the population here then would be the set containing all citizens of the city. Now, from there, you might want to look at doing a sample, right? Which means you're going to figure out, how can I take a sample of that population, so of all the citizens of the city, making sure that every group we need to be represented is represented. Look at example 2. A city government wants to conduct a survey among the city's displaced people to discover their opinions about required residence in city shelters from midnight until 6 a.m. What is the population? Well, in this case, they want to conduct a survey among the city's displaced people. That would be your population of study. All right. Again, that would be the population, but depending how big that is, if it's too large or too difficult, then that is where you want to get a sample. Okay, so that being said, let's talk about what are steps in a statistical study. Basic steps in a statistical study. 1, this is important, state your goal of the study. This is going to help you then create your next steps. What is your goal? And then that means you're also going to determine the population you want to study and exactly what you'd like to learn about it. Number 2, choose a representative sample from that population. 3, you're going to collect raw data from the sample and then summarize these data by finding sample statistics of interest. 4, use the sample statistics to now make inferences from the population parameters. And then 5, draw your conclusions. What did you learn from that study, and did it address your goals? And if so, how did it address your goals? Now, what we were talking about before is that the very first thing after you create your goal and you also determine what is the population you're going to study, how are you going to get a sample that's representative, unbiased, and random? Here are 5 different sampling techniques. 1 is a random sample. Now, with a random sample, the sample is obtained in such a way that every element in the population has an equal chance of being selected for the sample. For example, if I wanted to just randomly pick 5 groups of students or 5 students from my class, I would randomly choose a name. Now, I could maybe put names in a hat and then without looking, randomly pick those. Or there are random number generators that you can just pull up from your phone. And so I could have every student assigned by a number and then have a random number generator just randomly choose those students. The other one, number 2, systematic sampling. The sample is obtained by selecting a random starting point, and then you're selecting every nth item in a population. All right, so for example, maybe you have people coming out of a store and you want to survey them, and it's a particular store that you were looking for. Then you're going to choose, let's say you say, okay, every 5th person that walks out, I am going to question. So you're picking a number, so that way you're not choosing the people. You're not saying, oh, I'm going to interview you, or, oh, it looks like I want to talk to you. Nope, you're saying every 5th person regardless. I'm going to survey them. Then we have cluster sampling. The sampling consists of a random selection of groups of units. To select a cluster sample, we're going to divide a geographic area into sections, and then we randomly select the sections or clusters. So for example, if I'm looking at, again, students from my college, I want to look at their average math score, average math grade. Maybe because it's such a big population, but I'm going to do samples. Now we have 7 campuses. So what I would do is I would then select a cluster sample. So I'm going to divide students by their campus, so geographic area. Then I will randomly select students from each campus. So now I made sure that I'm getting a sample, which every student is representing from each campus. So I'm making sure that each campus has been represented in the sample. Stratified sampling. Now, this is where the sampling involves dividing the population by characteristics, but not geographic characteristics called stratifying factors, such as gender, race, religion, income, anything like that. And then you take random samples from that group. And we call those class or stratum. And then last but not least is a convenient sampling. It might not be the best one, but sometimes if this is all you have time for, hence the name, it's convenient. The sample is taken from data that is easily or readily obtained. So for example, you poll maybe the first 10 people that walk out of Building 7 on Valencia's East Campus. You're just going to grab the first 10 people that walk out. That would be convenient sampling. All right, let's kind of apply all of that. I'm going to read each one, and we want to think about which of these sampling techniques is being used. Of the 5, 1, viewers of the CBS network are classified according to age. And then a random sample of viewers from each age group is selected. Okay, so if we go back to what we just talked about, the 5 different techniques, which one did we say is when we put them into some sort of classification? That would have been the stratified. Okay, so the stratified one was where we put it into some sort of classification, and then we take samples from that. All right, number 2, every 10th Samsung television coming off an assembly line is checked for defects. That was the one where it was systematic, because we're just randomly choosing a number, but then we stick to that number. Number 3, a state is divided into counties. A random sample of 12 counties is then selected, and then a random sample from each of those 12 selected counties is selected. Think about, we talked about geographic locations, so this would be a cluster sample. Number 4, a door prize is given away at a home improvement seminar. Tickets are placed in a bin, and the tickets are then mixed up. Then a ticket is selected by a blindfolded person. So you're randomly selecting this ticket, right? You're not looking. So this is what we call the random sample. Last but not least, the first 30 adults leaving a theater are asked how much money they spend per week on entertainment. So obviously this one would be the last one we talked about, which is the convenience sample. All right, that actually ends our introduction, just with some few terminology and then different types of sampling techniques that we can use to ensure that when we are drawing from the population, that it is random, unbiased, but also representative.